Kelp forests are crucial for marine biodiversity and act as powerful carbon sinks, absorbing large amounts of CO2. The loss of these underwater forests has severe consequences for both the environment and the species that depend on them. The overpopulation of sea urchins that cause this loss of kelp forests are due to human impacts such as overfishing. The main predators of Kina are snapper and crayfish, both of which are key species for commercial and recreational fishers. With this unnatural lack of predators that control the population of the sea urchins within the reef, this balance is thrown off, leaving behind Kina barrens. Today, scientists across New Zealand working in places like Goat Island have made progress in reducing Kina population, and some kelp forests are starting to recover. However, the problem persists in many areas, and the effort to restore balance in the ecosystem is ongoing.
So as well as the sort of loss of kelp and you get the urchin barren forming, in some situations you also get a change to a turfing algae. So you've lost, you may not have sea urchins there, but the kelp's lost and you end up the reef just covered in a sort of carpet of small turfs, and that's sort of what this stuff is.
Scientists are racing to get a clear picture of sea urchin populations across the country, including both Kina and the invasive Centrostephanus.
So there's the endemic Kina, which is it's a taonga species. It's a really treasured species in New Zealand waters all around our country. And then the subtropical sea urchin Centrostephanus, which it's a native species, but it's also found in Australia. And that species is increasing in population quite significantly at the moment due to quite rapidly warming water conditions.
Accurately assessing their numbers is essential for developing strategies to protect New Zealand's fragile marine ecosystems.
When we are assessing their populations, we have a range of traditional methods that we would use. So the most standard and pretty widely used will be 1 metre squared quadrats. We do drop camera surveys for getting information over a large area. So these don't provide as detailed information as a quadrat, but it means we can cover a lot greater area in a day. And from that we can look at habitat characteristics, we can see what type of sea urchins are present, and assess the condition of the reef. So essentially works off the side of a boat, just like this one here. So we have the camera, which we'll put on now. Yep, so the camera just sits, and that connects via the Wi-Fi signal, comes back up to the boat, and then we just have the tablet at the surface. And then I guess a step further than that is using drones and satellite imagery to look for those characteristic signs of urchin barrens and kelp forests over regional scales.
Researchers such as Kelsey Miller are now seeking for more efficient ways to control sea urchin population.
Obviously, the best approach to trying to combat the overpopulation of sea urchins is through things like protection or bringing back the marine predators. And other strategies, active strategies such as Kina harvesting or removal, they can be quite valuable fisheries. We've seen that with species globally of sea urchins. Centrostephanus, in particular, Australia is putting in a lot of money to create a sustainable Centrostephanus sea urchin fisheries. In New Zealand here, kina has a lot of value as kai and for cultural aspects. Kai being seafood, kai moana is seafood that comes from food that comes from the sea.
There have been a lot of projects around the world looking at removal of kina and understanding how that affects the ecosystem. And across all of this research, almost all have shown that when you remove kina from a kina barren, the kelp and macroalgae will come back. And it happens quite quickly. So on average, about 18 months, which is much faster than, say, terrestrial forests. So we know that that part of the equation works, but it's a limited solution.
So, while the removal of kina solves the initial issue, the lasting problem lies in the complicated relation between sustainable, economical, and ecological fishing.